solving polynomials. Now, before we get into this, you need to put a big old note at the top of your paper. All polynomials must be equal to 0 before solving. Okay, it's just like with quadratics. With quadratics, we didn't want anything on the other side. It had to be equal to 0. Well, the same thing happens with polynomials. Now, most of the time, that's going to be the case. That's already going to be true. And if you look at all the ones on the front side of this worksheet, that is the case. All of these are already equal to 0. But just in case you run into one that's not, it's got to be equal to 0 before you start trying to solve. Okay, you can't have anything on the other side. Okay, so let's look at number 1, where our goal is to factor as much as we can possibly factor. So what's the first thing we always look for when we're factoring? A GCF. Does this one have a GCF? Yes, it has x. Okay, all those terms have an x in them. So if we take out an x, we reduce those exponents, right? If we take out an x, we've got x squared plus 5x plus 6. Okay, so can we factor x squared plus 5x plus 6 more? Anybody have any idea there? I think we can. Let's try it. X times x gives us x squared, right? What times what gives us 6 and adds to give us 5? 3 and 2. Positive 3, positive 2. Now, this is just like with quadratics. Once we get it to this point, we set each of these factors equal to 0. So we've got x is equal to 0. We've got x plus 3 is equal to 0, and we have x plus 2 is equal to 0. So the nice thing about x is equal to 0, that's already solved. We don't have to do anything there. We need to subtract 3 to solve that one for x, and we need to subtract 2 to solve the third one for x. So it's a third degree polynomial. We're expecting 3 solutions, and we just got 3 solutions. 0, -3, -2. Now, let's talk about plugging these back in. Because, let's think about the final exam. It's multiple choice. So if they asked you to do a problem like this, they would give you multiple choice answers that have the solutions written. You can just plug in the solutions and see which ones give you 0. Now, you do have to check all of them. All right, now the first one hopefully is pretty obvious that if you plug in 0 for all those x's, you're going to get 0, okay? Now, be careful with the -3. Anytime you have a negative and you're raising it to a power, you need to put it in parentheses every single time, okay? Whether it's squared, whether it's cubed, whatever it is, put that negative number in parentheses or it's not going to come out right. So -3 checks out, and then I'm going to press second enter and change my 3's to 2's because they were negative as well. Save myself a little bit of time, and I get 0 for that as well. Okay, no reason not to check these answers, guys. You can find very careless mistakes, simple mistakes, if you plug them back in and you don't get 0. Okay, let's look at number 2. Okay, similar idea with number 2. All those terms have an x, so we need to start by taking out an x. So we're left with x squared minus 6x plus 10. Okay, is equal to 0. Let's see here. Factors of 10 that give us 6. Is that possible? No, that's not possible. So when it's not factorable, what was our other option? If we couldn't factor it, what could we do? Quadratic formula, okay? We got to do the quadratic formula here. But we're just doing it on the quadratic part. Okay, so A is 1, B is -6, and C is 10. All right, so x equals the opposite of b. So b was -6, so now it's +6. Plus or minus the square root of b squared, -6 squared, minus 4 times a times c, all over 2 times a. Remember, when we do this, we just simplify what's under the square root. We want to find what number we need to put under the square root there. So again, parentheses, -6 squared minus 4 times 10. I'm going to do that in my head. 40, okay? But look at what that gives us. It gives us -4. What did we do when we got a negative under a square root? We put an I. Now, can we take the square root of 4? Yeah, we can, okay? So, not only am I going to put an I here, but the square root of 4 is 2. So, I'm just going to replace that square root of -4 with 2I. Okay? All three of those numbers are divisible by 2, so we can reduce them all by a factor of 2. So 6 divided by 2 is 3, 2 divided by 2 is 1, 2 divided by 2 is 1, so I'm not going to put over 1 because dividing by 1 is the same thing. Okay? And then that's only 2 answers. 3 plus I, 3 minus I. I'm supposed to have 3 answers. Well, don't forget about this x right here at the beginning. Okay? That gives us x equals 0. So here are our 3 solutions. 0, okay, just like the first one, if we plug in 0 for all those x's, we're going to get 0 as an answer. Let's check that 3 plus I thing. Okay, let's make sure we didn't make a mistake. So we just type it in. We put it in a set of parentheses, just like we would do a negative number. 3 plus I cubed. If you've forgotten, the I is second decimal. Okay, so 3 plus I cubed minus 6 parentheses 3 plus I squared plus 10 parentheses 3 plus I. Now, I don't know how on earth that's going to give us 0, but it does. I mean, I do know. But looking at it, you think, how on earth does all that equal 0? But it does. A whole bunch of stuff ends up canceling out. And you could check, if 3 plus I works, then 3 minus I is going to work. Okay, it's just kind of the way imaginary numbers work. But it can't hurt. Change those pluses to minuses there. 3 minus I. Check it as well. Okay, so those are our 3 answers there. Okay, let's look at number 3. Let's look at number 3. How can we factor number 3? It's got 4 terms. What did we just do today? Grouping. Okay, grouping is what happens when we have 4 terms. So let's try it. Let's see if that is the case. If we put x cubed plus x squared together, its GCF, or their GCF, is x squared. So that leaves us with x plus 1. What do we need to factor out of the second pair? -5. So that leaves us with x plus 1. When we take out a -5. Okay, so that's good. We got the exact same factor, x plus 1. We're supposed to. So we put the GCFs together, x squared minus 5, x plus 1. Can we factor x squared minus 5 anymore? No, because 5 is not a perfect square. So let's set these equal to 0. X squared minus 5 is equal to 0. X plus 1 is equal to 0. Which one y'all want to solve first? X squared minus 5 or x plus 1? X plus 1, yeah, it's a lot easier. So let's subtract 1 from both sides. So we get x equals -1. X equals -1, that's one of our solutions. Anybody have any idea of how we can solve that other one? We can add 5 to both sides, yeah, that's okay. So we get x squared is equal to 5. How can we get rid of that squared? Square root. We can take the square root. Now, what do we have to remember when we take a square root? What do we have to remember when we take a square root? How about plus or minus? Anybody remember that from math 2? You need to include the positive and the negative. That's where the other two solutions are going to come from. It's a third-degree polynomial. We're expecting 3 solutions. We've got one of them so far. We need 2 more, and we've only got one equation that we're solving. So those 2 must come from that one equation. So you've got to put the plus or minus anytime you take a square root. Okay, let's check this one really quick. Okay, let's plug in the -1. -1 cubed. Again, do not forget your parentheses. -5 times -1 minus 5. We get 0. Okay, you could do the same thing with the square root of 5. Place all those -1s with the square root of 5. And you get 0. Okay. So again, the reason why I'm taking the time to check these is to remind you that if you have answer choices to choose from, push comes to shove, you can just plug in the answer choices and see which ones check out and give you 0. Now, you don't have answer choices right now, so you got to be able to do what I'm doing, but ultimately, at the very end, you will. Okay? All right, let's look at x cubed minus 125. X cubed minus 125 is equal to 0. What's going on with that? How about the difference of perfect cubes? Is 125 a perfect cube? Yep. Okay. Don't forget about the stuff that we've done just recently. Okay. So this is x and 5. What goes in our parentheses? X squared, 5x, 25. So, same, opposite, always positive. So, I mentioned this the other day. This was the whole purpose of factoring perfect cubes, because we've got x minus 5 is equal to 0. There's one solution. Very simple solution to get. X equals 5. Use my red. Okay, x equals 5. One solution found. Okay, we need 2 more. Where are they going to come from? Well, they're going to come from this quadratic. But what did I tell you about that quadratic? Does it factor? That quadratic never factors anymore. Okay, so our only result or option is to do the quadratic formula again. A equals 1, B equals 5, C equals 25. So, if you don't know the quadratic formula by now, you're probably going to know by the end of today. The opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Sorry, I had to kind of go, oh, you can't see my 25 there. That's a 25 on the edge. Not just a 2, it's a 25. Okay, so we've got x equals -5 plus or minus. Let's see what happens under this square root right here. 5 squared minus 4 times 1 times 25. -75. So I'm going to automatically go ahead and put my I out here. Okay, 75 is not a perfect square. This is an example of one that simplifies. I'm not going to go through the process of simplifying it, but this one does simplify. So I square root of 75 is not going to be one of your answer choices. Okay, I'm going to go ahead and tell you it's not going to be one of your answer choices. So we've got to find its decimal so that we can compare it. -5 plus the square root of 75. You don't have to worry about the I part. Okay, that just sticks an I on it. Okay. Or actually, sorry, you do need to put the I in there. I don't know what I'm saying. Negative 5 plus I square root of 75, or it's not gonna work out. Okay, divided by 2. Okay, and then you're gonna type in your answer choices and see which one matches. Okay, you're gonna type in your answer choices and see which one matches. But this is the nice, pretty version, so to speak, of your answer. Okay? So, do y'all want to see me do a couple more, or do you think y'all are ready to try a few? Because y'all look incredibly bored. I don't know whether you're bored or completely lost. Both? Okay. So, let's try and overcome the boredom and watch me do a couple more examples, so hopefully we're not lost. Thank you for the honesty. All right, let's try another one. Let's do number 5. Okay? X cubed plus 10x squared plus 25x equals 0. So what should we do first? Find the GCF. Take out an x. They all have an x. So take out the x. X squared plus 10x plus 25. This is just taking everything you know about factoring up to this point and putting it all together. All right, so can we factor x squared plus 10x plus 25? Can we go further? Yeah, we can. Okay, we can find two numbers that multiply to give us 25 and add to give us 10. 5 and 5, right? 5 times 5 is 25. 5 plus 5 is 10. So let's look at our solutions. X equals 0, x plus 5 equals 0, and x plus 5 equals 0. So there's one. Subtract 5. Here's another one. X equals negative 5. Be careful with these signs, guys. Okay. Subtract 5. X equals negative 5. Well, we just got the same answer repeated twice. Okay. That happens sometimes. Okay. So when you see that, what you'll see on the answer key, you will see it will be written negative 5 MULT 2. Okay. What that stands for is multiplicity. Okay, multiplicity. It just means it's repeated. Okay, it shows up multiple times. Look for the root word there. It shows up twice as an answer. So 0 and negative 5. Negative 5 is an answer twice. So those are our 3 solutions. Now, we haven't looked at a graph yet, but remember that one of the strategies to solve equations is to graph them, right? We can graph any equation and solve it. So let's look at the graph of this one so that you can see how the multiplicity shows up. All right, so when we're graphing it and we're trying to solve, what are we looking for? Where it crosses the x-axis. So let's look at this graph right here. Okay, clearly it crosses the x-axis right here through the origin. Okay, it goes through there. I know it gets really, really skinny right there, but you can see hopefully that it crosses at x equals 0. So that's where that solution comes from. I don't see it crossing anywhere else, but look right over here. At negative 5, it touches the x-axis. So what's happened is we call that bouncing. It goes up, it touches, and it bounces back down. That's what happens when you have a solution or a root that is repeated or that has multiplicity. Okay, it's going to bounce. If it has even multiplicity, it's going to touch. It's not going to cross. Okay? It's going to touch. It's not going to cross. But don't forget, we can also look at the table. And at 0, our y value is 0. And at negative 5, the y value is 0. Right? That's what we're looking for when we're looking for solutions. Okay, let's do one more together, and then I'm going to turn you loose on trying some. Number 6, x cubed plus 27 equals 0. How can we factor that? Sum of perfect cubes, right? What we did yesterday. So let's do it. X and what number? 3. X and 3. So we square the x, we multiply x and 3 together, we square the 3. So, same, opposite, always positive. This is why your signs are so important, because if you don't get the right signs in here, it's going to screw up the quadratic formula, right? The quadratic formula is very sensitive when it comes to signs. So we've got x plus 3 is equal to 0. There's one solution, very easy to find. X equals negative 3. We need 2 more. So, we can't factor that. Okay, this is not factorable, so that means we have to use the quadratic formula. So a equals 1, b equals negative 3, c equals 9. So quadratic formula, x equals the opposite of b. B was negative, so now it's positive. Plus or minus the square root of b squared, make sure you put that in parentheses, minus 4 times a times c, all over 2 times a. So let's simplify. Let's find out what goes under our square root here. Negative 3 squared is 9, minus 4 times 9. So we get negative 27. I didn't leave myself to go ahead and put my I, so I'm going to have to do it now. X equals 3 plus or minus I square root of 27 over 2. The majority of the time, when you have the sum or difference of perfect cubes, your answer is going to have an I in it. Okay, your answer is going to have an I in it. Those other 2 solutions are most of the time imaginary. So keep that in the back of your mind. Okay, 27 is another square root that simplifies. 27 is another square root that simplifies. Let me show you what happens, because I think most of y'all can do this. Okay, I want to show you how to simplify this. 27, what factor of 27 is a perfect square? 9, okay? 9 times 3 is 27. The square root of 9 is 3, so we put 3 in front, and this other 3 right here, we can't take the square root of that's not a whole number, so it stays under the square root. Okay, so that's how they simplify their answers. Okay, they look at that number and they say, well, what factor of that number is a perfect square? So 9 times 3, the square root of 9 is 3, so that comes out. This other 3 is not a perfect square, so it stays under. Okay, let me look at this one. 75. 25 times 3. Okay, 75 is 25 times 3. The square root of 25 is 5, so 5 comes out. That 3 is not a perfect square, so it stays under. Okay, so that's where they get those answers from on the answer key. I think y'all do that in math too. Okay, so you should have seen it before. I just didn't stress over it before this point, but I did want to show it to you. Okay? All right, so with the time that we have remaining, I just want